Hi, I'm Ankit Asthana, a program manager on the .NET team. I'm going to be talking about how to use different tools and services available out there to infuse machine learning and AI for your .NET applications. Here's a rough agenda for this Connect video. In this Connect video, we will talk about the various tools and services Microsoft offers for building your own models or consuming pre-built and trained models. We will then cover pre-built models that Cognitive Services offers, Core ML experience for Xamarin iOS apps, and also explore what CNTK has to offer for deep learning. We will conclude with introducing a new language type, TensorFT in .NET, which is designed to provide an optimized exchange type for multidimensional machine learning data. We will understand its usage through a short demo, and at the end of the video, we will provide you plenty of resources. So let's get started. Microsoft offers a wide variety of tools and services for machine learning and AI. You can choose to build your own models or consume pre-built, already trained models. For consuming pre-trained models, C# developers can use Cognitive Services, Core ML for Xamarin iOS apps, and CNTK. Alternatively, you can also choose to build custom machine learning and AI models using Azure Machine Learning and popular deep learning and classic machine learning libraries like CNTK, TensorFlow, and Accord.NET. For this video, we will largely focus on consumption of pre-trained models with C#, while providing a few resources for folks at the end who want to build custom machine learning and AI models. The first one we want to talk about is Cognitive Services. Cognitive Services provides a variety of pre-built and trained models like vision, knowledge, language, speech, and search through REST API endpoints, which you can easily integrate into your C# application with just a few lines of code. You can try these APIs at Microsoft.com/Cognitive today. Next, we have Core ML for Xamarin iOS developers. Core ML lets iOS apps take advantage of pre-built machine learning models right on the device. To incorporate machine learning into your app, first find the models you want to use and understand what the input and output parameters are. Then you can compile it into your app, load the model at runtime, and get results almost instantaneously. Xamarin supports Core ML in Visual Studio, and the samples link provided here will get you started with Core ML and allow you to build iOS applications. Alright, let's move into deep learning now. CNTK is Microsoft's free open source deep learning library. CNTK provides support for a large variety of neural networks like LSTM, feedforward, and other deep architectures. CNTK is written in C++ but provides bindings in C#. The CNTK C# API will allow you for building, training, and also evaluating CNTK models. CNTK also provides a limited but rich set of pre-trained models which can be found at this link here. These pre-trained models include AlexNet, GoogleNet, and more, which you can use for your C# applications. Next, let's talk about TensorFT. To make it easy for machine learning libraries like CNTK, TensorFlow to expose their APIs to .NET applications while bringing in minimal custom dependencies, we're introducing a new type called TensorFT. TensorFT is really a container for your homogeneous multidimensional data for 1 to n dimensions. TensorFT is designed to provide an optimized exchange type for multidimensional machine learning data. It supports different layouts, sparse and dense, and provides efficient interop with native libraries like CNTK while ensuring minimal copies of data. You can try TensorFT today at .NET CoreFX Lab at this repo. TensorFT is going to soon become a part of base class libraries. Alright, let's now take a look at how TensorFT and CNTK can be used together today with the help of an MNIST pre-trained CNTK model. So here we have a simple WPF application which recognizes handwritten digits using convolutional neural network MNIST model. Let me show you the app very quickly. The app is fairly simple. It allows me to draw a handwritten digit, and on hitting recognize, it goes ahead and recognizes the handwritten digit. So how does this all work? Well, if you take a look at the Solution Explorer and you take a look at the file selected, this MNIST convolution.model file is a pre-trained, pre-built CNTK model which is checked into this app. The model itself is loaded using the function.load CNTK API. The loaded function provides inputs and outputs which describe the shape, dimension to pass and receive from the CNTK model itself. Next, I want to show the evaluate method. The evaluate method is called when the recognized pattern is hid from the app. The evaluate method takes in a bitmap image and converts it into a tensor type using the convert image to tensor data method. In order to initiate a tensor of t, we first need to understand the shape, dimensions, in this case the width and the height, which are loaded from the model itself. Once we understand the shape and dimensions, we can go ahead and create a tensor, in this case a dense tensor. The boolean at the end, which is set to true, decides whether the tensor is going to be row or column major. CNTK is column major, so currently this is set to true. Next, we go ahead and invert our image using this loop. The reason why we have to invert our image in this case is because our image currently has a white background and our drawing is black. The MNIST model, however, we trained on expects to have a black background and white drawings. The inversion itself is done by this line here. This line can also be used to highlight the beauty that the tensor of t brings in. In this case, the stride calculation for you happens automatically. In the absence of a tensor, a user will have to do the stride calculation manually by hand using code that looks like this. Next, I want to show you the tensor type in the debugger. For doing so, I'm going to set a breakpoint here and start my app again. I'm going to draw out the same digit that I used earlier, hit recognize, which is going to break the debugger on the breakpoint that I set. I'm going to refresh Vimeo and bring it up in the text visualizer. You can see now the tensor image data loaded up in this visualizer. Notice the data set is being populated from left to right instead of top to bottom. The reason for that is because in this case this tensor is column major, hence the data set looks transposed by an angle of 90 degrees. The last thing I want to show you is the final call made to the CNTK evaluate method. In order to call the CNTK evaluate method on the model, we first need to populate our input data map and output data map. The input data map is populated by calling the createBatch CNTK method, which takes in the tensor type. Notice that we can actually now use tensor types to call directly into CNTK APIs. Once the input and the output maps have been populated, the evaluate method is called on the model itself, using the input data map and the output data map. The output data will then result in returning one single-digit output, which is a list of 10 floats. This also represents then the likelihood of that index being the digit that we're looking after, or we drew out in the app. The digit is then sorted by the highest confidence and returned for preview into the application layer itself. So there you go. We showed you how you can use CNTK, the new tensor of t type, to infuse AI and ML into your .NET apps. Thanks for watching this video. I hope this video provides you a high-level overview of different tools and services available to you as a .NET developer. Go ahead and try some of these tools and services. Please also leave us a feedback note below in case you have questions.